Hello and welcome back. In this lecture, we'll talk about inner functions and closures. A function defined inside another function is called nested or inner function. Inner functions can access variables of the enclosing scope. Let's see an example. I am defining a new function simply called outer. Inside the function, I am declaring a local variable, msg equals, and a string, Python. Inside the outer function, we define another function that references the msg variable. def inner, this is the name of the function, and I'll print out the msg variable. msg between curly braces is really cool. And after defining the inner function, we call it. I'm gonna call the outer function and then run the script. And it printed out Python is really cool. Now let me explain what happens behind the scenes. The inner function is created only when calling outer, not when outer is created. The outer's body is executed only when outer is called. The variable msg is called non-local or free variable for the inner function. Now we'll try something different. Instead of calling inner inside the outer function, we return it. So return inner without calling the function, so without parentheses. We've seen in the last lecture that it's perfectly legal to return a function from another function. This is what high-order function means. What happens when we return inner? We don't return only the function, but also its free variable called msg. This is referenced inside the inner function. When we return inner, we return in fact a closure, which is the inner function plus its own non-local variables. In this case, there is only one variable, msg. Let's assign fn equals outer. Now fn is the closure, and if we run it, we get the string Python is cool. Let's call fn, and I'm running the script. And I've got the same string Python is cool. Does it seem weird to you? Let's think for a minute. When we write fn equals outer, Python executes outer, and when it finishes the execution, all its local variables like msg are going out of scope. Yeah, in Python all variables local to a function are destroyed and not accessible anymore after the function has finished its execution. So how it's possible to have access to msg variable after outer went out of scope, so after it has finished its execution? And the answer is that this is because of the closure which captured the value of that variable. So when outer finishes running, the closure still has that value. As a conclusion, you can think of a closure as an inner function plus an extended scope that contains the non-local or free variables. At least a free variable is a must to create a closure. By the way, we can get a list of all free variables of the closure in form of a tuple like this. fn dot dunder code dot co underline free vars. This statement will print out the free variables. And there is only one, msg. If you want to modify a non-local or free variable inside the closure, you declare that variable non-local before changing it. For example, x equals 1, and inside the inner function, I write non-local x. Then I can modify x. For example, x plus equals 1, print x. We see that the value of x is 2. If I don't declare x non-local, I'll get an error. Unbound local error. Local variable x referenced before assignment. We've discussed about this in the scope lecture. The use of non-local keyword is very much similar to the global keyword. Non-local is used to declare that a variable inside a nested function is not local to it, meaning it lies in the outer enclosing function. Fn is a function. Its inner, the returned function, so we can call it. And I've done this on line 14. Let's call it Fn again. And the new value of x is 3. Let's call Fn again. Now the value of x is 4. And we notice that a closure saves the stakes and the values of non-local variables between calls. One more detail. If I don't declare x non-local and I write x equals 10, a local variable to that name is created inside the nested function, so it will always print out 11. The value of x is not saved between functions calls.